Hello viewers, welcome again to today's lesson. This is the Solution Space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want to treat a new topic with you, and that is right-angled triangle. Right-angled triangle. As you can see from the board, I've written right-angled triangle on the board, okay? And on the right-angled triangle, we are going to learn a theorem that governs it, and that is Pythagoras theorem, okay? As you can see from the board, I've written Pythagoras theorem on the board, okay? So that's what I want to teach you in this video, okay? And you can see that I have a diagram on the board, okay? And this is a diagram of a right-angled triangle, okay? And for you to be able to identify any particular triangle as a right-angled triangle, there's one key thing that you are supposed to note, okay? And that is there's always a 90 degrees angle being formed inside the triangle, and that is what makes the triangle a right-angled triangle, okay? I'm going to repeat it one more time, okay? I'm saying that for you to be able to identify a particular triangle as a right-angled triangle, there's one important thing that you're supposed to note, okay? And that is there's always an angle of 90 degrees that is being formed inside the triangle, okay? And that is what makes the triangle to be referred to as right-angled triangle, okay? So you can see that there's a 90 degrees being formed here, okay? So this symbol or this mark here represents a 90 degrees angle that is being formed there, okay? So anytime you see a triangle which has a 90 degrees being formed in it, okay, a 90 degrees angle being formed in it, it means that triangle is a right-angled triangle, okay? So this is an example of it, okay? And this is the 90 degrees angle being formed here, and I've explained to you that this mark or this symbol here represents the 90 degrees angle that is being formed, okay? And you can also see that I have another angle here, okay, and that is theta, okay? And that is going to help us to talk about the Pythagoras theorem, okay? So before we go ahead and talk about the Pythagoras theorem, I'm going to label the vertices of the triangle, okay? So let's do that, okay? So I'm going to label here A, okay, here B, and here also C, okay? So you can see that the triangle has three sides, okay? And each of the side of the triangle has a name, okay? And I'm going to show you, okay, very soon, okay? So now you can see that we have three sides of the triangle, okay? I hope you are following, okay? So we have this side of the triangle, this side, and this side as well, okay? So this side is line AB or line BA, okay? Or you can refer to it as length BA or length AB, okay? It has a name, okay? And which I'll show you very soon, okay? And we have this side of the triangle also, which is length BC or line BC, or you can say line CB. Is the same thing, whether you say line CB or length BC or line CB is the same thing, okay? And we have this side of the triangle as well, which is line AC, or someone can say line CA or length AC or length CA. It's actually the same thing, okay? So now you can see that this side, which is line AB or length AB, okay, you can see that it's opposite to the angle which is here, okay, which is theta, okay? So that side of the triangle which is always opposite to the angle theta which is formed here is called the opposite, okay, because it is opposite to the angle theta which is here, okay? So this line AB, okay, or length AB, which is opposite to the angle theta, is called the opposite. I hope the explanation is clear enough up to this point, okay? So I'm going to write my opposite here, okay? So here is our opposite. Okay, so this side is the opposite. Okay, because it is the side which is opposite to the angle theta, which is formed here. Okay, so line AB is referred to as the opposite. Okay, so now we have this line also, line BC, okay, or length BC, okay, which is the longest side of the triangle. Okay, so always you see that the longest side of the triangle is what we refer to as the hypotenuse. Okay, so this line BC, you can see that from the size of the triangle, the line BC is the longest side. Okay, so always the longest side, which is mostly the slanted side of the triangle, okay, and also the longest side is referred to as the hypotenuse. Okay, so line BC or length BC is called the hypotenuse. Okay, so I'm going to write my hypotenuse here. Okay, so hypotenuse. Okay, so now we are left with this side, okay, which is the side which is the base of the triangle. Okay, so that is line AC. Okay, and also it has a name. Okay, and that is the adjacent. Okay, so the side of the triangle, okay, which forms the base of the triangle, okay, which is normally at the base of the triangle. So in this case, you can see we have line AC here at the base of the triangle. Okay, so that is referred to as the adjacent. Okay, so here is the adjacent. Okay, so the adjacent. Okay, so these are the size of the triangle, okay, and the names given to it. Okay, so I'm going to go over one more time, okay, so that you get a better understanding of it. Okay, so the side which is opposite to the angle which is formed here is called the opposite. Okay, so this side is the opposite, line AB or line BA. Okay, is the opposite. Okay, and the longest side of the triangle, okay, is called the hypotenuse. Okay, so this side which is the line BC is called the hypotenuse. Okay, and the part of the triangle which is the base of the triangle, okay, which is here we have AC, the line AC is called the adjacent. Okay, so these are the names of the sides of the triangle that you are supposed to know. Okay, I hope you understand and you agree with me up to this point. Okay, now the Pythagoras theorem that governs this right angle triangle, it says that, and please I want you to follow carefully. Okay, it's very important to pay attention here. So we are now going to talk about the Pythagoras theorem. Okay, so now it says that the square of the hypotenuse is equals to the sum of the square of the opposite and the adjacent. Okay, I'm going to repeat it one more time. Okay, so the Pythagoras theorem, okay, of the right angle triangle says that the square of the hypotenuse is equal to the sum of the square of the opposite and the adjacent of the triangle. Okay, so now the opposite here is the line AB, the adjacent here is the line AC, and the hypotenuse here is the line BC. Okay, and the theory says that the square of the line BC, okay, which is the hypotenuse, is equal to the sum of the square of the opposite, okay, and the adjacent. Okay, so we are going to have our line BC squared is supposed to be equal to line AB squared plus line AC squared, and that's what the theory says. Okay, so I'm going to write it down. Okay, so line BC squared, okay, I hope you are following. Okay, is supposed to be equal to line AB squared, or someone can say line BA is the same thing. So line AB squared, line AB squared plus line AC squared, so line AC squared. Okay, so this is the Pythagoras theorem. Okay, I hope the explanation is clear enough up to this point. Okay, it says that the square of the hypotenuse, okay, which is the line BC, the square of it should be equal to the sum of the square of the opposite, which is line AB squared, okay, plus the adjacent, the square of the adjacent, so line AC squared. Okay, so this is the Pythagoras theorem, okay, formula. Okay, I hope the explanation is clear enough up to this point. Okay, so when the triangle is being turned in a different way, it's the same rules that you are going to apply. Okay, so assuming, let's say the triangle is turned this way. Okay, so let me draw another triangle here. Okay, so let's say I have my triangle turned this way. Okay, so there's a 90 degrees angle being formed here. Okay, let me label the parts. Let me say I have my A here, my B here, and my C here. Okay, so it's the same process, and an angle theta being formed here. Okay, so the theory says that the square of the hypotenuse, okay, I've explained that the longest side of the triangle is referred to as the hypotenuse. Okay, so the line BC here is the hypotenuse. When the triangle is turned, it's the same thing. Okay, the same principle holds for it. The longest side is always the hypotenuse. The side which is opposite to the angle theta, which is formed here, is called the opposite. Okay, so this side is the hypotenuse. The BC, the length BC is the hypotenuse. The length AB, okay, or BA, which is the same thing, which is opposite to the angle theta here, is the opposite. Okay, and the side which is at the base of the triangle, okay, which is line AC or line CA, which is the same thing, is the adjacent. Okay, so the same rules apply to it even when the triangle is being turned. Okay, so this is our hypotenuse, the longest side, which normally is the slanted side, and this is the opposite, okay, because it's opposite to the angle theta here, and this is the adjacent, okay, which is at the base of the triangle. Okay, so the square of the hypotenuse, okay, should be equal to the sum of the square of the opposite and the adjacent. Okay, so we are going to have our line BC, okay, square, which is the hypotenuse, should be equal to the sum of the square of the opposite and the adjacent. So it's going to be line AB square, okay, which is the opposite here, plus the adjacent, which is line AC. So AC square or CA is the same thing. Okay, so whilst they turn the triangle like this, is the same principles that we follow. Okay, and that gives the Pythagoras theorem. Okay, so I hope the explanation was clear enough and you understood it as well. Okay, so I'll come your way again in another video whilst we use this theorem or formula to solve questions. Please don't forget to like the videos and also share them after watching. Bye bye.